Hello everyone, myself Gauri Sanoni from KK Arts Formal Science and Computer Science College, Nagar, Pimpras, Ramachi. Today I can explain you volumetric analysis in basic analytical chemistry. In this topic we are going to study the molarity, normality, mole fraction and stoichiometric concept. So let us start with in detail. Firstly, volumetric analysis. It is the general term to method the quantitative chemical analysis with the amount of substance is determine the measurement of the volume that the substance occupies. Second topic, it is commonly used to determine the unknown concentration of a known reactant. Okay, is it clear? Volumetric analysis is often referred to a titration, a laboratory technique in which one substance of a known concentration and volume is used to react with another substance of a unknown concentration. Next is the volumetric analysis and involves the preparation, storage and measurement of volume of a chemical for analysis. This is the volumetric titration. First, a process in which standard reagent is added to a solution of analyte until the reaction between the two judged complete primary standard. Next is the end point. The point at which the reaction is observed to be completed is the end point. The end point of volumetric method of analysis at the single that tells the analyst to stop adding reagent and make the final reading on the burette. The last point of the end point is observed with the help of indicator. The equivalence point, the point at which equivalent stoichiometric amount of titrant is added to the analyte based on the stoichiometric equation. Volumetric analysis involves a few pieces of equipment. The first one piece is pipette and second is burette. The pipette means for measuring accurate and precise volume of solution. This is the use of pipette. And burette for the pouring measure and volumes of the solution. A requirement for successful volumetric titration. Reaction must be stoichiometric, well-defined reaction between titrant and analyte. Second, reaction should be rapid or fast. Okay, reaction should have no side reaction, no interference from other foreign substance, must have some indication end point of reaction such as color change, sudden increase in pH, zero conductivity, etc. No relationship between end point and equivalence point. This is the requirement for volumetric titration. Definition of terms. First is the concentration. It is a general term expressing the amount of solute containing is a given material expressed by different ways. First one is the molarity. It is denoted by capital M, the number of moles of solute divided by the number of liters of solution containing the solute in grams per molecular weight dissolved in 1 liters of the solution. This is the molarity. Molarity is equal to moles of solute per volumes in liter, millimoles of solute per volumes in milliliter, and moles is equal to weight grams in molecular weight. Millimoles is equal to weight in mg or milligram divided by molecular weight. Next definition is normality. It is denoted by capital N, defined as the number of equivalents of solute dissolved by the number of liters of solution containing solute. Gram equivalent weight dissolved in 1 liters of solution. Normality is equal to equivalent of solute per volume in liters. Next is the milli equivalent of solute per volume in milliliters, and equivalent is equal to weight grams divided by equivalent weight, or milli equivalent means weight milligram upon equivalent weight. This is the definition of normality. Relations of normality and molarity, or difference in normality and molarity. Firstly, molarity is equal to weight per molecular weight into volume. Molecular weight is equal to weight per molarity into volume. Similarly, second is the normality. Normality is equal to the weight per equivalent weight into the volume. Equivalent weight is equal to weight into normality into the volume. The equivalent weight is equal to molecular weight divided by H, where H is the reacting unit. For acid, H plus is the reacting unit, and for base is the OH minus. For oxidation reduction, electron is reacting unit. For ionic species in valences, the difference of normality and molarity, molarity having the molar solution and normality is the equivalent weight. Next, equivalent weight means it is defined as the part by weight of substance in which chemically equivalent to 1 part by weight of hydrogen or 8 part by the weight of oxygen or 35.5 parts of weight of chlorine. Thus, finding out equivalent weight, we find out how many grams of that substance are directly or indirectly equivalent to 1 gram of hydrogen. It depends on reaction in which it takes place. Next definition is weight percent and their formulas. Second, volume percent, and third is the weight percent. The firstly, weight percent, it is denoted by W upon W. This is the weight symbol. Weight of analyte divided by weight of sample into 100. Volume percent काढायचं असेल तर volume of analyte upon volume of sample into 100. Weight percent, W upon volume. W means weight upon volume is equal to weight of analyte into 100. Next, parts per million. This is the ppm. Parts per million is equal to weight of analyte divided by weight of sample into 10 raised to 6, or that is 1 gram is equal to 1 gram per 10 liters. 1 milligram is 1 milligram per liters. Microgram per ml. Molar solution. Grams molecular weight dissolved in 1000 gram of solution. Formal solution. Gram formula weight dissolved in 100 ml of solution. Use of density value. Commercial acid and bases are available in percentage by weight and by further dilution solution are prepared. Density is equal to weight unit volume at a specific temperature 20 degrees Celsius, unit gram ml of gram per centimeter cube. Specific gravity is equal to mass upon mass of equivalent volume of water at 20 degrees Celsius. At 4 degrees Celsius, density of water is 1.00000 gram per ml. And last topic is the stoichiometry, the branch of chemistry which deals with the weight relation between reactant and product is called stoichiometry. For example, the HCl react with NaOH. HCl is the acid and NaOH is the strong base. According to the example, HCl plus according to the equation, HCl plus NaOH to give the H2O plus NaCl. NaCl is the salt and water. And the molecular weight, the HCl is 36.5, NaOH is the molecular weight is 40, water 18, and NaCl is 58.5 gram. 36.5 gram of HCl is equal to 1000 ml of 1 molar NaOH. The 1 molar, the 0.0365 gram of HCl is equal to 1 ml of the 1 molar NaOH, and 0.0365 gram of HCl is equal to 1 ml of 0.1 molar NaOH. This is the molarity concept or the stoichiometry concept. Thank you for watching the video, and thank you.